Good evening, I'm Charles Schultz, and this is the Randomizer for the 9th of May 2022. And tonight we're going to be covering an interesting and useful topic, something a lot of people don't think about, derived units. So we know we have a system of measure that's used for everything, and while there are competing systems of measure in the world, the United States is really the only country that doesn't use the metric system. Although, honestly, when in England, I noticed that they measure everything in miles, you know. So it's just kind of an off-the-cuff definition. Everybody on Earth uses metric except the US. Yeah, mostly true. However, there are many units in the system, and we're going to get into those basic units and then what derived units are. And this is something that affects all of us. So I think it's going to be interesting, an interesting explanation all around. So very quickly, we are changing our randomizer schedule to Mondays and Fridays at 6 p.m. Eastern Standard Time. We've got a whole library of randomizer episodes built up now, and we're going to continue to add to them. Also, we're making some changes in how we're doing some things on the site. We're adding more material, more content, and that is proceeding apace. So I encourage everybody to go to schultzlaboratories.com or universesciencecenter.com. Walk through our galleries, put your Oculus on or your Vive if you have one. Enjoy it in 3D. Walk through, use the interactive exhibits. And if you're an educator or you have some skills that you wish to share with people, we can create a virtual classroom and gallery for you to show off your works and to share your educational skills with people all around the world. It's something that I find is really engaging and entertaining. And if you really want to get into the virtual world, this is an easy way to do it. So, also, our robotics classes are continuing on Monday nights at 9 p.m. Eastern Standard Time, and they will continue. We may even extend. There's a lot of fascinating things going on in the class. Come to the Schultz Laboratories page and sign up for the robots classes. I think you're going to really enjoy seeing it. We'll be posting all of the episodes of that, all the lessons, very shortly. So, back to the subject at hand, derived units. All of us went to school and had some education in the metric system. And I don't think a lot of people are really aware of how our nation made a commitment to go to metric, and it has been going on for quite a while. To be honest, I don't think they're going to get there quite soon. The person who set this program to go to metric in motion was Thomas Jefferson. So I think they're a little behind schedule. However, the metric units are actually very useful for a number of simple reasons, one of which, if you try to convert miles to feet to yards to chains or whatever, you get into a lot of complicated math where divisions and ratios and things start cropping up. Whereas in metric, you simply move a decimal point in almost every case. However, when we start getting to units in nature, we notice there are sometimes sloppy measures of, how far light travels, how many meters, not quite 3 times 10 to the 8th meters per second, 299 something thousand or million meters per second. And you're wondering, well, why is it such an oddball number? We're going to get right down to that very shortly here. So when we talk about fundamental units, those are the units that we use as the foundation for everything that we measure. And in the English system, of course, we have strange things like teaspoons and cups and ounces and gallons and imperial gallons and long tons. And we can dispense with all of that and go to the very simple basics. For instance, what do we need to measure? Well, there are 7 fundamental or basic units. And the first of note is the second. So a second is your basic unit of time. And if you really want to know the meaning of a second, it's defined as being so many billion oscillations of a cesium atom under the certain conditions that make it oscillate. And that number of oscillations, if you count exactly how many it is, should give you 1 second. So the second is our basic unit of time. Then for length, we've chosen the meter. And the meter has an interesting history. Navigators and people around the world have had different units to use over time, but the meter was eventually settled on because it was supposed to be an exact number of units in circumference around the Earth from pole to pole. And it isn't exactly, but it was pretty darn close, and so it's a good unit. And the meter is defined in a specific manner, just as the second is. And so there is an exact integral number of meters in 1 second at the speed of light. So if we measure the speed of light, it becomes a fundamental reference for distance as well as being a unit expressed in time. So now we come to an interesting point. We have a fundamental unit of time and a fundamental unit of distance, but if we multiply the two together, we get a rock solid unit as well, known as speed. How many distance units did you cover in 1 second? So you can see how a derived unit is created. So our fundamental units also go on to cover mass. The kilogram is the basic unit of mass, and the ampere, the basic unit of electric current. And people simply call it amps, how many amps are flowing in the circuit. In other measures that we find very important, temperature, obviously, and the Kelvin is the unit of temperature. To put it into perspective, we measure temperature by different units and different scales based on different things. But if you go to absolute zero and measure in units of kelvins, room temperature is around 300 degrees Kelvin. And the sky temperature of the universe has a temperature of around 2.67 degrees Kelvin. So it's an extremely cold temperature, and it's basically the microwave noise left over from the beginning of the universe. And other units we use, the mole. And if you ever took chemistry, you know what a mole is. It is an exact quantity of material. So if you had, for instance, 1 gram of hydrogen, that would be 6.023 times 10 to the 23rd power atoms of hydrogen. So that's about 0.6 trillion trillions of atoms. That's how many it takes to make 1 gram of hydrogen. And a nickel is about 5 grams of material. So that gives you a sense of perspective. And then we have a final unit called the candela of luminous intensity, how bright a source of light is. And so these 7 units, the second, the meter, the kilogram, the ampere, the Kelvin, the mole, and the candela, those 7 units are fundamental to everything that we do. And to be certain, there are units in nature that don't have any convenient size or form. So we've based all of these on these units in a way that we can get an exact measure based on physics and actual matter and actual forces. But those 7 fundamentals are your basics. Everything else is a derived unit based on it. Now, of derived units, there are 22 that I'm aware of that have specific names. And some of these things have, there are a lot of derived units that don't have a special name. For instance, what's the unit of area? Well, we take the meter and we multiply it by itself to make a square. So a square meter, a meter squared, that's the unit of area. And the unit of volume as a consequence is the cubic meter. It's a box that's 1 meter tall, 1 meter wide, and 1 meter in extent, depth. So we can see how these are derived. They're based on the basic unit of length. So when we start talking about derived units, they're not somehow inferior to or different from the others. They're basically composites based on combining the other units in useful manners. For instance, speed. Okay, if you're going to measure speed, you can measure it in how many meters something travels per second, as mentioned earlier. So meters per second is a basic unit of speed. If you wanted to measure acceleration, you would say meters per second squared. Well, why squared? It's because you have a certain amount of change in your speed every second, and it's a rate of meters per second per second. So it's a rate of change. So acceleration is not an absolute, it is a rate of change, but it is a derived unit. So now most of the things that we measure end up being these derived units. And many of them, as I said, don't have a name. Units of force do, the Newton, and the Newton is the same as a kilogram of the force necessary to move 1 kilogram a meter per second in a second. And when you start thinking about things in these terms, you see why a lot of people shy away from physics. When we talk about energy, we measure it in joules. Well, what is a joule? And a joule is literally, think of it as if you had a water pipe and water spilled out of the pipe until it filled a certain volume, then you would say, well, this is a gallon. Well, a joule is like a gallon, but it's in terms of energy. So it is the amount of energy represented by a mass of a kilogram moving at a meter per second, striking an object, and it would deliver 1 joule. Now, that means in order to take something that with a mass of 1 kilogram and get it moving at 1 meter per second, you would have to apply a joule of energy to it. So you can see definitions, strange terms that we may not be familiar with. That's one of the fundamental issues that drives a lot of people away from some of the technical, like physics, some of the technical fields. And yet what you discover when you get there is the mathematics behind it is actually very basic. It's very simple. You simply have a unit multiplied or divided by another unit, in many cases, giving you this derived unit. So derived units are very much the tools we use in our lives to describe most of the things, the changes or forces or elements around us. So when we talk about, for instance, density, how would you describe density without saying how much matter you had in a certain volume? And that's exactly what density is. Now, there's another term, specific gravity, which is related to density, and that is the density of an object minus the density of water that it would be in, for instance. And there's a long running story about a king making a crown out of gold. But when the crown was finished, he wondered, is this pure gold or was some silver mixed in, lowering the amount of gold in there, and maybe I got ripped off a little here. And so he went to a specific, very famous and well-known, intelligent Greek philosopher and physicist, and said, let me ask you something, Archimedes. I have my crown. How do I tell if it's actually pure gold or if there's some silver in there? And so he went on for a while thinking about this, and he had a hard time trying to figure out exactly what it would take to find the answer. And he was at the public baths, and he lowered himself into the bath and watched the water displaced and thought about the fact that he seemed to weigh a little less. And this displacement was the thing that struck him. And all of a sudden, this is where the famous line, Eureka, emerged, which means I have found it. And off he ran, so excited, reportedly with nothing except a scrap of fabric to cover himself, to work out the solution. Well, now, specific gravity is what he discovered. That when you have something that has a certain weight and you immerse it in water, it will weigh a little less, but it will displace an exact amount of water equal to its volume. And so this was his insight, that the weight of the object divided by its volume would tell you just how dense it was. And it was known that gold was more dense than silver. And by the way, if you wonder about gold versus, let's say, lead, gold is 1.6 times more dense than lead. So if you think lead is massive, gold is much more so. To put it in perspective, imagine those TV shows where a guy has a box of gold and he's carrying it. Not going to happen. That stuff is incredibly heavy. It's more dense than lead, and it doesn't take much of it to reach your limits. So, and I go back to a specific very old James Bond movie, which, I don't even need to mention, Goldfinger. But Anyway, the basic units we know are all metric, and the derived units that we use, the 22 named ones, are all metric. And when you come right down to it, it's a very useful system. The derived units are the ones that do the real legwork for us. They're the ones that we usually use the most. Although the second isn't to be scoffed at, nor the meter. So if you really want to know anything about anything, in physics or in science, you need to know your math and you need to know your units. And by the way, one of my favorite scientists was known as Lord Kelvin, and he said, and I will paraphrase, if you don't know anything about it in numbers, if you can't express it in numbers, you don't know a thing about it. And I think that's probably one of the best summaries of what physics and science and math come together and teach us. If you can't express it in numbers, you don't know a thing about it. It's just an opinion. So, if you look at fundamental units, look at units of pressure, of force, of energy, of density, and those derived units are all based on the fundamental units. So you can have a lot of fun with it. I remember as a kid learning that they expressed butter in firkins, and prunes in punches, and fabric in ells. And what it really taught us was that you can name anything you want, but if everybody doesn't understand what the unit is, you're going to get cheated every time. You never know what you're getting. With a solid set of references and numbers, the metric system and the basic units, you can always figure out if you're getting what you bargained for. And that's true whether you're smashing particles together or weighing a stick of butter. So learn the fundamental units and learn your derived units, and you'll discover that most everything, even the volt, is a derived unit. So, wow, a lot of people in electricity don't know that. And so you might just mention it to somebody who seems to know a lot about electricity but might not have taken the physics behind it. The amp is derived, is basic, it's defined, and the volt is based on the amp. In fact, 1 volt flowing at a current of 1 amp through a resistance of 1 ohm is a single unit. It is a single product. All three of them together. 1 volt through 1 ohm flows with a current of 1 amp. And so now you can see how the fundamental unit, the amp, ties the volt and the ohm together. And if a volt flows at 1 amp for 1 second, that's 1 watt, and you end up with 1 joule. So your basic units are always your reference points for all of these derived units. The fundamental units are always the ones that you come home to in the end. Everything is based on those. So without dragging this out, I am going to open the floor for questions, and I will say again, please come to Schultz Laboratories or Universe Science Center. Become a member and support our growth and the addition of new galleries and exhibits and interactive content. And if you ever have any questions, please join us live Mondays and Fridays at 6 p.m. Eastern Standard Time. Bring your questions, your comments, whatever issues you have, and we'll try to answer them for you. No sports questions, please. This is just science and technology. So I see no questions on the floor, and I'm going to say, well, I will read my quote for the day. As he came from his mother's womb, naked he shall return, to go as he came, and he shall take nothing from his labor, which he may carry away in his hand. And that is Ecclesiastes 5:15. The bottom line here is, none of the stuff you earn in this world that you can carry around will ever go with you when you die. The only thing that goes is what you've done to improve your mind and your understanding and what you've done to help those around you. Learn everything you can. Make yourself a more functional and valuable and smarter person. And be kind to those around you. Everybody's facing a battle you don't know. Be ready to lend assistance to those who need help. And I know a lot of people never run out of the need for help, but we become discerning over time of that. And have patience. People are just learning their way. This is a tough world. Well, I appreciate everybody showing up for the randomizer, and I hope that you learned something interesting today about derived units and fundamental units. And we'll have another randomizer Friday. We'll pick another technical subject out of the blue and have a lot of fun with it. So if you have any suggestions, send them to us. If you have a specific question, send it to us. We'll see if we can address it for you. Well, everybody, thank you for showing up, and thank you for watching the randomizer. I'm Charles Schultz with Schultz Laboratories, and make the world a better place. Thank you.